How many quantities, factors we see here? I see 1, I see 2, I see 3. How many of them will have positive in front of the log and how many of them will have negative in front of the log? It depends on how many come from the top and how many come from the bottom. Only the ones coming from the bottom will have negative in front. So then what do I write? Natural log x cubed plus natural log, very good, but minus natural log of x1 plus 1 to the 4th power. Correct. Perfect. Now the last property that I have to apply is which one? Or which rule? The power rule. So the power goes in front as a factor. So this is 3 natural log x. What power is the square root? Which power? The square root. 1/2, so it goes in front. Natural log of x squared plus 1. And finally, this power goes in front as well. We expanded. We used all properties. There is nothing else. Let me caution you that this may be tempting. It may be tempting to say that this is log x squared plus log 1. Don't. There is no such rule. The 3 rules are applied to log applied to a product, ratio, or power, not to a sum or difference. So no one can simplify these in any way, shape, or form. Now let's go backwards. We want to condense this time. So let's say problem 58. So this is condensing now. Condensing log expressions. So 58 on page 501. And this is 2 natural log x minus 1/2 natural log y. So this time we are given 2, or subtraction of 2 logs, and we want to come up with something like this, with 1 in front of it and all the expression together condensed and only 1 log. Okay, what property do I have to apply first in order to condense this? Say it again. Yes, yes. So when we see, thank you, Kyle. So when I see this number in front, I know it's coming from the power of x. When I see this, I know it's coming from the power of y. So then this is natural log x, very good, minus natural log of the square root of y. Do you all agree so far? So now how many have the negative in front of log? How many quantities have negative in front? 1. Only that quantity will go to the denominator. So this will be natural log, only 1, applied to what? Do you all agree with x squared over the square root of y? And this is it. We condense this expression to 1 log. Let's look at other problems. Let's say 67. Any questions for me? Any questions here? Okay, 67. 1/3 bracket 2 natural log of x plus 5 minus natural log x minus natural log x squared minus 4. Close the parenthesis and close the bracket. It's the same question. We want to condense into 1 log, nothing in front of the log, actually 1, but no other no other number, and just one log. I have to start inside the brackets. This is okay. It's completely cleaned up. This is okay. It's completely cleaned up. There is 1 in front. But this one has a 2. I have to bring it back to the power where it came from first. So this is 1/3 and bracket natural log of x plus 5 squared minus natural log x minus natural log x squared minus 4. Now, how many logs have negative in front? Yes. Can anyone condense what we have in brackets? In one step. Natural log of, other than Kyle. For once I was faster than he is. So. No, no.
1/3 x. So ln x. Okay, never mind.
How many have plus in front? 1. So what do I put at the top then? What do I put in the bottom? So I'm not sure whether it's clear, and if you don't say anything, I don't know what to do. It's the property is not clear, or how to apply it, or okay, so now we have to remove this. Is this clear what we're doing here? If I want to expand it, I will have natural log of this minus natural log of x minus natural log of this. Is that better?
I'm not clear. Why did you change that? Why did you change that one day?
What did I do? Where is my... Okay. Oh, here it is. Log applied to a sum, log applied to a product is a sum of logs. So if I have a sum, I can go back and write log of the product. Then log applied to a ratio is the difference of logs. If I have a difference, the log with minus in front will send this quantity to the denominator. And then the power rule, in which a number in front is coming from the power, or the power is going in front, depending on what I'm doing. Is that better?
Yeah. Okay.
Very good.
That makes sense.
Good.
But in the other thing, it looks like there were 3 terms.
Yes. 1, 2, 3. 2 of them have minus in front, they go to the bottom. The other one has positive in front, it goes to the top. And now this number in front becomes the power of the whole thing. So natural log of the cube root x plus 5 squared over x times x squared minus 4. And we condensed, what did we condense? All this into one log with coefficient of 1 and a complicated, if you want, expression. Is that better? Yes? Okay, let's do another. Is that okay? Very good. So let's choose another. Okay, let's take a look at 70. Log x plus log x squared minus 4 minus log 15 minus log x plus 2. How many logs have positive in front? How many logs have negative in front? Good. So what will you tell me? Just 1 log of what? Applied to what? Very good. Very good. That's it. Is that better? Yes? Very good. Do you think we need another example? Or are we feeling better about this? I couldn't hear, sorry. Not really. We are applying the 3 properties of the log to condense the expression. This is useful for the next section. Do we move on? Or we want another example? Anyone? We are okay? Okay, very good. So in that case, let's continue with 4.4, exponential and log equations. This is another preparation for applications. That's why we do this. Let's start with exponential equations. We do have a little bit of experience with them because we looked at one example last time. And I'm just going to refresh your memory. It looked like this. And we said we don't simplify, we don't divide, we don't cancel. Nothing happens here. We just look at it and think. 2 numbers are equal and they have the same base. What has to happen to their exponents? They must be the same. Very good. So that's why from here we got that x plus 1 equals 2 or x equals 1. This was the simplest possible exponential equation. Now we are going to build on this and look at a few more, like this one, and then slightly more advanced. So let's say problem 20 on page 514, in which we have 8 raised to 1 minus x equals 4 raised to x plus 2. So looking at this, I'm going to ask myself, first of all, what type of equation is it? It's clear that it's an equation because it has the left-hand side equal symbol and the right-hand side. So what type is it? Is it an absolute value? Is it a square root? Is it? Of course, thank you. It is an exponential equation. The variable is at the exponent level. It must be exponential. Okay. My next question to myself is this: can I, and I hope I can, present both bases, both sides, on both sides with the same base? So is there a way of presenting 8 and 4 with the same base? And the answer is yes. How? To the, very good, everything to 1 minus x, and the right-hand side, 2 squared raised to x plus 2. Perfect. Now, I have to apply a property, an exponential rule property that says a raised to the mth power, everything raised to the nth power. I copy the base, and what happens to the exponents? Add, subtract, or multiply. There is nothing else. We multiply. Very good. So then on the left-hand side, we have 2 raised to which power? Very good. So I'm actually back to the simple situation, correct? I'm saying this to myself. Two numbers are equal and they have the same base. What must happen? The exponents have to equal to each other. 3 minus 3x equals 2x plus 4. It's linear. I move 2x and I move 3. Negative 5x equals 1. Therefore, x equals negative 1/5. Any questions? Do we need another example like this one? Very good. Of course. Okay, and let's say number 19. We have 9 raised to x equals 1 over the cube root of 3. Yes, it's exponential, and I hope that I can present both sides with the same base. Let's look at 9. What base will that be? Squared. 3 squared raised to the x. I'm really hoping that I can present the right-hand side with base 3 as well. But is it possible? The answer is yes. How? Right, so I will replace the bottom by 3 raised to, no, the cube root cannot be power 3. 1 over 3. The cube root is 1 power 1/3. Power 3 is one thing. It's 3 cubed. The cube root is power 1/3. Good. So the denominator is 3 raised to 1/3, this piece. This is 3 raised to 1/3. But I want it now at the top. So what do I put? It's 3 to 1/3 in the denominator, and if I want it to the top, what do I write? It must be negative, right? 3 raised to negative 1/3 is 1 over 3 raised to positive 1/3, correct? Yes? Good. So now the left-hand side, I copy the base. What happens with the exponents? Very good. Awesome. And 3 raised to negative 1/3. I'm back to the simple situation. Two numbers are equal and they have the same base. What has to happen to their exponents? Awesome. Thank you. So 2x must equal negative 1/3. What do I do to both sides to get the solution? Very good. So I get negative 1/6. This is it. Do we need more examples of this type? Is that a yes? Is that a no? Yes, one more. Very good. Let's take a look at 22. E to x plus 4 equals 1 over e to 2x. It's exponential because the exponent has the variable, no doubt. Now I'm asking myself, can I present both sides with the same base? Yes. The left-hand side is clear. There is nothing I can do. It's just e to x plus 4. But what about the right-hand side? Something that we just did. Say it again. Yes? Yes. How do I write it? Perfect. Yes. Awesome. Because e to negative 2x is 1 over e to 2x. Very good. We are back to the same situation. Two numbers are equal and they have the same base. What has to happen? Very good. Which means x plus 4 must equal negative 2x. Linear equation, I move x to the other side. 4 equals negative 3x. X equals negative 4/3. Questions? This is okay? Okay. So now let's look at the next level of exponential equations. Like, let's say 5 raised to x minus 3 equals 137. I picked problem 38. On the same page, 514. Now, regardless of how much we really would like to have the same base on both sides, in this case, it's impossible. There is no way I can present 137 with a base of 5. Okay. Let's look at the following example for a moment. When we solve this equation, what did we do? Exactly. Why don't I cube? What do I have to square? The square root and x squared are inverse functions, not with a cube, right? So that's why I had to square both sides. It's like I'm giving you $10 and I take it back. No deal. Okay. Now let's look at this. I really want to apply a mechanism to both sides like I did here. What was the mechanism I applied? I squared both sides. Now here, I would like to apply something that allows me to take this power and put it in front. Because solving such an equation with the power, a variable being the power, I really don't know what to do. But if I could bring this down somehow, applying the same thing to both sides like I did here, squaring both sides, then I can solve for x. What mechanism will that be? Which function I should apply to both sides that has the property that allows us to bring x minus 3 in front? Which one? Log, very good. So I will apply natural log to both. Oops, not before the equal symbol, sorry. But after the equal symbol. My apologies. Very good. So I applied, like I squared, here I have to apply a different function. Here I apply the function x squared. Here I have to apply the appropriate function that will allow us to bring x minus 3 in front. So then we have x minus 3, and it must be in parentheses. Natural log 5 equals natural log 137. Now let me caution you on, or give you some advice. If any of these two is 10, then I will not apply natural log. I will apply common log, log. If any of these two is e, definitely I will apply natural log. If I have 5 and 137, it doesn't matter. I will apply one of the two that I have in the graphing calculator, not base 5 or 7 or 35, right? So either natural log or common log. Good. How do we proceed? I know that this could be intimidating because I see a number and then a function in front of it. It's just a number. So don't get scared about these two numbers, just simple numbers. What will you do next? We are trying to solve for x. And just remember, these are like simple numbers. What would you do? You can, okay, let's divide. By what? No, not by 5. I cannot separate these two. Yes, I agree. I divide by natural log, that's perfect. And then I get x minus 3 equals natural log 137 over natural log 5. Perfect. That's a very good idea. And what would be the next step? And the final step, actually. I add 3 to both sides. Okay. So now, let's suppose I don't trust my work, or I do trust my work, but I want to be super sure that this is correct. I would like to check. Okay. So the first thing I would like to ask you before we check with the graphing calculator, is it okay, you tell me, if I check in this equation, the solution we got, or in this equation? Are they the same? Of course, they are the same. This equation and this equation are completely the same. If I move this term to the other side, doesn't mean that I have a new equation. It's equivalent. They have the same solution. Would you agree? You will see now and further in other examples why I want to do this. So first I will evaluate, I will get an approximation with a graphing calculator, and then I will plug it in this equation, not in that one. It's the same thing. The number I get to make sure that I get 0. So with the graphing calculator, please, if you have it, clear everything you have. And I need to determine 3 plus natural log parentheses 137, close the parenthesis, divide by natural log, parentheses already there, 5, close, and press enter. So the approximate solution is x approximately 6.056956. Do not delete what you have. Keep it as is. So now I'm trying to check. 5 power in parentheses. I call the previous answer second and answer minus 3. Close the parenthesis at the top. Bring the cursor down minus 137. When I hit enter, if the solution 6.0 blah 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 is correct, what should I get? Zero. Yes. I'm checking in this equation, right? I'm checking in this equation. I plugged in for x this number by recalling the previous answer. And I got in one statement, in one calculation. I don't have to put in both sides. I put in one side and see if I get 0. Any questions on this? Anyone needs help? Are we okay? Okay, let's look at another problem. So it turns out that this is the exact solution. It's correct, exact. And this is the approximation. And we checked, it was easier to, it's always easier to check in this equation than in this one, because here if we have powers, then you will not be able to recall the previous answer. You will have to do more calculations to put in the entire answer. Okay, so here's another. (34) e to 1 minus 8x equals 7,957. I know it's exponential. The question is, can I present both sides with base e? The answer is absolutely not. So I have to find, or there is a different mechanism that allows us to solve this equation. So what will I do? Since this base is e, e goes with natural log. So can you apply a common log? Yes. Will you get the correct answer? Of course. But because one of them is e, I will use, at least one of them is e, I will use e. Natural log. Natural log on both sides. Then 1 minus 8x goes in front times natural log e equals natural log of 7,957. Now here's a question for you. A side question before we continue. If I have log in any base of the base, log base 9 of 9, log base 1/2 of 1/2, common log of 10, natural log of e, what do you think we get? Don't say anything and just let's change it into an exponential equation. From the base counterclockwise, the base raised to which number is a? A raised to which number is a? What exactly? So that's why this happens to be 1. Because the base is e, and we're applying natural log to base e. So therefore, I have 1 minus 8x equals natural log 7957. And this is, don't get intimidated by this. This is just a number. Now the equation is linear. How do I proceed? Very good. Negative 8x equals negative 1 plus natural log 7957. Negative 8. 1 over 8 minus 1 over 8 natural log 7957. Awesome. Any questions on this? Any questions? Questions? Okay, one more and then we continue with log equations. This, I would say, is a little longer than the previous ones. Yes, exponential equation, yes. Both sides with the same base, no way. 7 and 3 cannot be presented with the same base, there is no doubt. So there must be another mechanism that will help us solve this equation, and the mechanism is what? Apply log or common log, natural log or common log to both sides. Which one would you like? It doesn't matter now. It's 7 and 3. If it's base 10 or base e, it won't make any difference. Which one? Natural log. Very good. Good. So the left-hand side, what do I write? Awesome. That's what I wanted to hear. I need to put the power in parentheses. If I don't put the power in parentheses, I'm only considering 1 as the factor. So I have to have parentheses. Equals. Very good. We are solving for x. Let me draw your attention where x is. Do not get intimidated by these two. They look sophisticated. They're not. They're just numbers. I want to solve for x. What should I do? What would you recommend? These are just numbers. These are numbers. Just this is 15 and this is 20. As an example. Of course, it's not 15 and 20, but what would you do? What do you think? No, I have x on both sides. I can't divide yet. I have to distribute. Awesome. Thank you. 2x natural log 7 plus natural log 7 equals x natural log 3 plus 2 natural log 3. Of course. Because I have two terms that have x. I have this term that has x in it, and I have this term that has x in it. Awesome. What will be the next step now after I distribute? Not yet. I can't. They're not like terms. What do I have to do next? I can solve if one term with x is on one side and another term with x is on the other. I can't solve yet. Say it again. Of course. This has to go here and this has to go here. I have to separate the terms. It's linear. It's a linear equation. I have to separate the terms with x from the terms without. So 2x natural log 7 minus x natural log 3 equals 2 natural log 3 minus natural log 7. Awesome. We'll look at another example in a minute. Okay, now what? Now you will say, combine like terms on the left. And I'll say, I'm sorry, I can't. There must be another way. whenever I cannot combine like terms. There must be another way. And there are two big keywords. There are many keywords in this class, but two big ones. One is simplify, and the other one is factor. Which one? Can't? Factor out the common factor. Very good. Awesome. What is left in parentheses? Very good. Now we are ready to do what? What operation now? Which one? Which operation? These are just numbers. Exactly. These are just numbers. Don't get intimidated. In order to solve for x, I have to divide by this. It will be a terrible mistake to start or attempt to simplify. This is it. Would you like us to check this number or this solution, or would you like the next problem? Okay, very good. Here it is. 42. No, this was 42, sorry. 41. 5 raised to 2x plus 3 equals 3 raised to x minus 1. Can I present both with the same base? No. So 1 minute, let's work on this. Same identical steps. Very good. We apply natural log to both sides. 2x plus 3 in parentheses, natural log 5 equals x minus 1 in parentheses, natural log 3. Awesome. Next step. Very good. 2x natural log 5 plus 3 natural log 5 equals x natural log 3 minus natural log 3. Awesome. Move terms with x to one side and terms without to the other. 2x natural log 5 minus x natural log 3 equals negative 3 natural log 5 minus natural log 3. Perfect. Yes, because I cannot combine like terms. Awesome. X in parentheses. What do I have in parentheses?
2 natural log 5 minus natural log 3.
Awesome. And the final step. Yes, divide by what's here. Very good. Awesome. Not too bad, right? Second time around, not too bad. Any questions? Any questions? Okay, let's look at log equations now. Question. When we solved rational equations, did we state restrictions? Rational equations, did we state restrictions? Yes, we did, because the denominator could not be 0. Awesome. When we solved exponential equations, did we state any restrictions? No. Why? Because the exponential function is defined on all your numbers, no restrictions. If it's defined on all your numbers, no restrictions. Well, log is not defined everywhere. So when we solve log equations, we have one of two options, but you must you must use one or the other. Nobody will indicate or force you to use one or the other, but you have to use one that you prefer. The first one is check solutions. Of course, back in the original problem, like we did with radical equations. When we squared both sides, we went back to check. Same thing here. I do not do that. You can. It's up to you. I prefer to state the domain. Why? For two reasons. I state a domain because I want my students to remember how to find the domain of a log function. That's one very important reason. And the second very important reason is I tend to forget to go back and check. So if I write a domain, probability is much lower than I would forget. So for those two reasons. Let's start with a simple example now. Let's say 58. Page 515. Log base 2 of 4x plus 1 is 5. Okay. I see a log, and I'm asking myself, okay, what is the domain of this function? Look at log base 2 is applied to 4x plus 1. What type of number must 4x plus 1 be for the log to exist? Exactly, very good. So 4x plus 1 must be strictly greater than 0. Or 4x must be greater than -1, or x must be greater than -1/4. So what is the domain of this function? There is only one function in this equation. What is the domain? -1/4, strictly greater than -1/4, comma, infinity. So if I solve the equation and I get x equals -5, will you accept it as a solution or not? If we solve that equation and we get -5, would you accept it as a solution?
No.
No, of course not, because -5 is not here. What if we get 0? Will you accept it as a solution?
Yeah.
Yes, because 0 is in the domain. Awesome, that's the idea. Very good, so then I have no idea how to solve this, but I know I can change it. Of course, this is not the only way. I'm just making a point. I can change it into an exponential equation. Remember how? Always from the base. Base raised to this number equals this number. Counterclockwise. 2 raised to the 5th power must equal this. So 2 raised to the 5th must equal 4x plus 1. What type of equation is this now? No, because the exponent is not a variable. 2 to the 5th is 32. So 32 equals 4x plus 1. So what type of equation is it? Of course. I subtract 1, I get 31 equals 4x. Therefore, x is 31 over 4. Well, if it's there, then 31 over 4 is acceptable. If it's not there, 31 over 4 is not acceptable. Is it? Yes, it is. So I will say yes. This is our first log equation.
So is that what it means by check your solution?
No. If you want to check the solution, then you don't state the domain. And you have to put it in here and check.
Oh, okay.
That's how we check. We go back to the original problem, we substitute x with the values we got, and see if we got 5 on the other side. I prefer the domain, as I said, for two reasons. Number one, I want my students to remember how to find the domain of a log function. And number two, I know myself, sometimes I forget and move on to the next problem. Okay. So next problem, problem 69. Log base 3 of x plus 6 plus log base 3 of x plus 4 equals 1. Okay, this is a log equation. I see two functions, one applied to x plus 6. It's a log applied to x plus 6. The other one, log base 3 applied to x plus 4. So what is the condition for this one? What do I have to write? For this log to exist, very good. What do I have to write for this one to exist? Good. This one means greater than -6. This one means greater than -4. I need to find the common domain, as we did in chapter 2. Let's say I don't know where it is. I'm going to graph both and see what happens here. From -6 to infinity, I don't care for units. And from -4 to infinity, I need a territory where both functions exist. Very good, indeed. -4 to infinity is the common domain. If the solution or solutions are not strictly greater than -4, they cannot be accepted as solutions. Very good. So now I need to condense the left-hand side as we did before. That's why we learned how to condense and expand log equations. I'm sorry, log expressions. So where does this come from? Log base 3 of where is my, okay. This is one property going back and forth. This is the second property going back and forth. And this is the third one. Which one? Very good. The first one. What do I write? Yes?
Log 3 x plus log.
I already have that. It's the other side now. It's the other side. We don't have log applied to a sum. There is no rule for log applied to a sum. Log applied to a product is the sum of logs.
X plus 6 times.
Yes, indeed, equals 1. Log applied to a product is the sum of logs. Is that clear? So then log base 3, I will distribute x squared plus 4x plus 6x, 10x plus 24 equals 1. I think it's not clear. Is it or not? It's okay. Please say no if it's not clear. Let's go back. Log applied to A times B. That's the product rule. Log applied to A times B is log of A plus log of B. Back to the rule. Log of A times B is log of A plus log of B. Log of A plus log of B is back log of A times B. So then in our problem, we have log of A plus B. That's why we have log of the product. Log of the product is the sum of logs. The sum of logs is the log of the product. Is that better? We'll have more examples in a minute. Okay, so then I multiply these two and I got this. X squared plus 4x plus 6x plus 24. So now, what do you think I'm going to do? What is it? 3 raised to 1 equals this. 3 to the first power equals x squared plus 10x plus 24. We change it into an exponential equation. But now, this is not an exponential equation anymore. It's what type of equation? We've solved so many in chapter 2 and 3. What type of equation is it? Very good. It's a quadratic equation. So therefore, we need everything set equal to 0. Oops, I didn't mean that. Subtract 3 from both sides and set it equal to 0. We know 4 methods of solving quadratic equations. 4. Will I complete the square? Absolutely not. Will I take the square root? No, because it's not set up like that. So I'm down to 2. What are the other 2? Factor or quadratic formula. If factoring takes a blink, why not? If it doesn't, quadratic formula. So then the equation appears to have 2 solutions. What are they? Not so fast. Otherwise, you have to go back, replace x everywhere by -7 and check, or go back and after that go back and replace x by -3 everywhere and check. Okay, let's look at another. Let's say 72. Log base 4 of x plus 2 minus log base 4 of x minus 1 equals 1. Please tell me what to do next.